Welcome to my channel, The Magic of Math. Today our lesson is solving simple equations. Our objective today will be to solve simple equations using addition, subtraction, multiplication, or division. And another word for simple equations would be one-step equations. Let's review some vocabulary. So we have variable. A variable is a symbol that represents one or more numbers. An equation, a statement that two expressions are equal. Solution, a value that makes an equation true. Equivalent equations, equations that have the same solutions. I'll point this out today on a different slide. And inverse operations, they are two operations that undo each other. And a zero pair, two numbers whose sum is zero. So these are equations, these are 6 vocabulary words that I will be referring to and using throughout this presentation, throughout the lesson. So inverse operations. We have addition that undoes subtraction, and subtraction undoes addition. They are inverse operations. And then we have multiplication and division. And then division undoes multiplication. So we have two sets of inverse operations here. Addition and subtraction undo each other, and vice versa. Multiplication undoes division, and division undoes multiplication. We're going to be using this idea in our lesson today. Let's talk about the addition property of equality. That property states that adding the same number to each side of an equation produces an equivalent equation. So we have the algebraic equation x subtract 3 equals 4. If we add 3 to both sides, this is the addition property of equality. I'm keeping the balance. So this equal sign says that this expression is equal to this expression. So think of it as a balance scale, and you want to keep the balance. So if I add 3 to this side of the equal sign, I must also add 3 to this side of the equal sign, also known in math as the addition property of equality. So now we're going to combine. So negative 3 and 3 are a zero pair, meaning they are opposites. When I add them, I get 0. So on the left side of the equation, all I'm left with is x, because this is a zero pair. Then 4 plus 3 on the right side of the equal sign is equivalent to 7. So it produces the solution, which is also an equation, x equals 7. So this is an equation, and then we started with an equation. These are equivalent equations, because when we simplify this or solve this, we get an equivalent equation, which is also our solution. Now we have the subtraction property of equality, which states that subtracting the same number from each side of an equation produces an equivalent equation. So here's a different equation, and I'm going to subtract 6 from each side. Again, thinking of this as a balance. So whatever I do to the left side of the equal sign, I must do to the right side of the equal sign to make it remain equal. That's the equality property. So when I go to simplify this, this is a zero pair. I picked subtracting 6 from each side to force this to be a zero pair. So I'm left with x, and then 11 subtract 6 is 5. Again, x plus 6 equals 11 is an equation that is equivalent to the equation x equals 5. And this is also our solution to our equation. All right, let's try a few examples. So we want to solve this equation, and we don't want to forget to check our solution. So in the previous slide, I focused on the properties that we use to solve it. As we move forward, I'm also going to focus on, I want you checking your solutions. So let's see, we have x subtract 4. So the inverse property of subtract is to add. So I'm going to add 4 to each side using the addition property of equality. This is a zero pair. Negative 4 and 4 are a zero pair, leaving me x. And negative 6 add 4 is negative 2. So here's my solution, x equals negative 2. Now this time I'm going to check my solution. So to check, I'm going to take this value that says what x is, and I'm going to replace it in the original equation. So you can see that I've replaced x with negative 2. So if I had x here, it would look like the original equation, x minus 4 equals negative 6. So all I've done is taken my solution and substituted in for x. Now I'm going to evaluate. Negative 2 subtract 4 is negative 6. And negative 6 equals negative 6, so it checks. Let's try one with subtraction, and we're going to check our solution as well. So now I have 0.7, or 7/10, is equal to y plus 1.9, 1 9/10. My goal is to get y alone. I need to isolate the variable term because I want to know what y is equal to. So right now we have add 1.9. So the inverse of add is to subtract. So I'm going to subtract 1.9 from both sides of the equation using the subtraction property of equality and creating a zero pair. When I simplify, I get y, because this is 0, and 0.7 subtract 1.9 is equivalent to negative 1.2. So I know that y is equal to negative 1 2/10. Let's check. So to check, I'm going to take my solution, negative 1.2, and go back to my original equation and replace y with that value. So you can see this is where y was, and I've replaced y with negative 1.2. So now negative 1.2 plus 1.9 is 0.7. Statement of equality, it checks. Okay, let's solve an equation with pi in it. Remembering that pi is not a variable. Pi is a symbol that replaces a number. It's a specific number. The difference between pi being a symbol and a variable that can represent any number, pi cannot represent any number. Pi is specifically 3.14 and continues on with no pattern infinitely. It's an irrational number that does not end. So pi, the symbol, replaces in an equation a number, an exact number. Okay, so sometimes we use pi instead of using 3.14 because 3.14 is rounded. So pi is more specific. So pi is different than a variable because this is an unknown number, x, but pi, we know what it stands for. So this is a value. This is a constant. This is a variable. And I want to know what x is equal to. So I'm going to do the inverse of add 3 pi. I'm going to subtract 3 pi from both sides of this equation using the subtraction property of equality. Remember, this is a zero pair, so I'm left with x. And 7 pi minus 3 pi equals 4 pi. So think of it as 7 cookies. Take 3 cookies away, subtract 3 cookies, you've eaten 3 cookies, you have 4 cookies left. So pi and cookies kind of are the same. All right, let's check our solution. So we're going to go back to our original equation and replace x with 4 pi. So here we go. 4 pi plus 3 pi is 7 pi. It checks. 7 pi is equivalent to 7 pi. Okay, your turn. I'd like you to pause and complete this on your own. Check your work. Come back and check your answer. Welcome back. So we're looking for the inverse operation of add 5. Hopefully you used the subtraction property of equality and subtracted 5 from both sides, resulting m equals negative 14. To check our work, we're going to take negative 14 and put it in for m. Negative 14 plus 5 is negative 9 equals negative 9. It checks. Here's another one. Go ahead and pause, complete your work, come back and check. Okay, so we want to do the inverse of subtract 1.7. So we're going to use the addition property of equality and add 1.7 to both sides. This being our zero pair leaves us g is equal to 0.8. Now let's check our work. We're going to replace g with 0.8. 0.8 subtract 1.7 is negative 0.9 or negative 9/10. So it checks. Try another one. Okay, so I'm solving for k. I want to do the inverse of add 3. So I'm going to use the subtraction property of equality and subtract 3 from both sides. Having my zero pair, I'm left with k, and negative 3 subtract 3 is negative 6. Let's check. We're going to replace k with negative 6. Negative 6 plus 3 is negative 3. It checks. One more. Okay. So I want to solve for r, reminding you r is the variable, r is our unknown. So we want to use inverse operations. We want to undo subtract pi. So we're going to use the addition property of equality and add pi to both sides. Here's my zero pair, so I'm left with r, and pi plus pi is 2 pi. So 1 pi plus a second pi is 2 pi. Let's check our work. We're going to replace r with 2 pi. So 2 pi minus pi equals pi. And remember, in math, there's an invisible 1 here. That's 1 pi. 2 pi minus 1 pi is pi. It checks. Try this one. Okay. So I want to undo subtract 1/4. So I'm going to add 1/4. Adding undoes subtraction. These are inverse operations. So using the addition property of equality, I'm going to add 1/4 to both sides, creating my zero pair, resulting in t equals negative 3/4 add 1/4 is negative 2/4, and that can be simplified, so t is equal to negative 1/2. Let's check our work. So I'm going to replace t in the original equation with negative 1/2. Negative 1/2 subtract 1/4 is negative 3/4. Get a common denominator. Remember, this is equivalent to negative 2/4. Negative 2/4 minus 1/4 is negative 3/4. So it checks. Let's move on and talk about the multiplication property of equality, which states that multiplying the same number to each side of an equation produces an equivalent equation. So let's start with the equation x divided by 3 is equal to 4. We're going to multiply both sides of the equation by 3. I picked 3 because that is undoing. Multiplying by 3 is the inverse or opposite of dividing by 3. It will undo division. So I'll be left with x because 3 divided by 3 is 1. So when you solve, 4 times 3 is 12, so our solution is x equals 12. Reminding you that this equation, x divided by 3 equals 4, is an equivalent equation to x equals 12. We also have the division property of equality, which states that dividing the same number from each side of an equation produces an equivalent equation. So let's start with the equation 2x equals 8. So 2x is also referred to as 2 multiplied by x. There's an invisible multiplication symbol in between this constant, this coefficient, and its variable. So to undo multiply by 2, I'm going to divide by 2. So I must divide both sides by 2 to keep equality. 2 divided by 2 is 1, leaving me x. 8 divided by 2 is equal to 4. So my solution, my equivalent equation or my solution is x equals 4. All right, let's try another example. Often students get confused with this. We have -3/4 multiply by n is equal to -2. So here's the magic. We need to remember the word reciprocal. We're going to multiply both sides of this equation by the reciprocal, because when you divide, often students learn to keep, change, flip, or multiply by the reciprocal. So when you divide a value by a fraction, you end up keeping, changing, and flipping or multiplying by the reciprocal. So when you have an algebraic equation, we're going to skip that keep, change, flip and just know now that we are going to multiply by the reciprocal. So I'm going to multiply both sides using the multiplication property of equality by the reciprocal, which is the same as dividing by -3/4. Multiplying both sides by -4/3 is the same as dividing by -3/4. So I'm going to multiply both sides by the reciprocal. This is going to give me 1, so I'm left with n. -2 multiplied by -4 is +8, all divided by 3. Let's check our work. So I'm going to replace n with 8/3. -3/4 times 8/3, so -3 times 8 is -24. 4 times 3 is 12. And -24 divided by 12 is -2. It checks. Let's practice one with division. So now we have pi being multiplied by x is equal to 3 multiplied by pi. I want to find out what x is equal to, so I need to undo multiply by pi. The inverse of that is to divide both sides by pi using the division property of equality. When I do that, pi divided by pi is 1, leaving me x. 3 pi divided by pi is 3, because pi divided by pi is 1. So we're going to check replacing x in this original equation with 3. So now we have pi times 3 equals 3 pi, which is also written 3 pi. So it checks. So over here, it's your turn. I want you to solve the equation 6 times pi is equal to pi times x. Welcome back. So hopefully you used the division property of equality and you divided both sides by pi, resulting in 6 is equal to x. Checking your work, 6 times pi is equal to pi times 6. 6 pi equals 6 pi. Try this one. Okay, so we have y divided by 4. So we want to undo. We want to do the inverse of dividing by 4. The inverse of divide is to multiply. So we're going to use the multiplication property of equality to multiply both sides by 4, which results y is equal to -28. We're going to check, replacing y with -28. -28 divided by 4 is equal to -7. -7 equals -7. It checks. Sometimes you'll be asked to find out what value makes an equation true. The value that makes the equation true is the solution to the equation. So this is a little funky, but they've written a division sign in here, and we need to use order of operations. So we want to divide first, because using order of operations, PEMDAS, parentheses, there aren't any, exponents, there aren't any. So we want to multiply and divide in order from left to right first. So first we need to find 4 divided by 0.2, which is 20. So now I'm going to replace this, rewrite my equation with 20. So k plus 20 is equal to -5. Now I have my simple equation. So I want to undo this add 20. I want to create a 0 pair. So I'm going to subtract 20 from both sides, resulting in k. 5 subtract 20 is negative 15. So the solution, or the value that makes this equation true, is negative 15. So that's our lesson on one-step equations. I hope you'll subscribe to my channel. Give us a thumbs up. Thanks for joining me today.